That's right. Physics is about describing the nature as precise as possible. It's neither simple nor useful for anything. Even physicists refuse to use it when not necessary. When it comes to electricity, physics provides us with Maxwell's equations. Those are 21 equations. Oliver Heaviside, presumably the first electrical engineer and inventor of the whole field of electrical engineering, turned the equations into four simple ones we learn today. Those four equations hold water, except for the quantum world, as far as I know. So we can think of physics as coding rules, as source code, describing the behavior of physical realities. The source code is short, and physics compress the universe of electricity into some mathematical rules. Physics aims to find lossless rules. That means physics tries to describe exactly what happens for every eventuality. And that makes it uneasy. Maxwell equations are three-dimensional and make use of useless physical quantities like electric fields. You want to have something simple. Those new simple rules are lossy. That means you must always keep the inaccuracies in mind while using them. But it should be much simpler. Those lossy rules are used in the field of electrical engineering. Compare Maxwell against Ohm's law. Ohm's law is never correct, but it is correct enough. Note that Ohm's law contains strange physical quantities like voltage and resistance. Those non-existent quantities are absolutely not part of Maxwell. Electrical engineering invents those pseudo-physical quantities nature has never heard of. That's okay when it works. Let's take resistance. You might say, resistance is real, I can measure it. Well, if that's so, you can probably tell how electrical resistance is created in the first place. If not, let me tell you, it's a bunch of strange quantum physics about phonon vibrations and stuff. So if you really want to do physics here, you will not come anywhere if you want to build something useful. Instead, you must invent some model which captures the essence of all the strange and unintuitive physics going on. That is resistance, a single value, a simple value. Does this make electrical engineering a bit dumb? Or is the simplicity ingenious? Or is it neither of it? Or is it just practical? You decide. We will hear about electrical engineering concepts that match the ingenuity of physics. So what I want to motivate here is the idea that physics is not electrical engineering. In fact, electrical engineering refuses to touch physics with a 10-foot pole if not absolutely necessary. Electrical engineering does not use physical models. It makes its own. Electrical engineering is a science of modeling physics in simple and useful ways, creating abstraction layer on abstraction layer until we arrive at microprocessors, instruction sets, and assembly language where the realm of informatics begins. Electrical engineering disconnects itself from physics as far as possible and tries to abstract physical concepts. Physics is a field of science. Electrical engineering is another field of science. The 10th or so abstraction layer of physics is where informatics can be applied. And the 15th or so abstraction layer of physics is called Facebook. Yes, humankind went on a century-long journey to find Facebook. In this course, we explore the space of analog circuit design in a lot of its beauty. We scratch some topics just for the hell of it, and we will gradually turn to more complex circuits.